Hello there. In this video, we'll be learning about the squeeze theorem. So, the squeeze or sandwich theorem states that if we have a function g of x and it is between another function f of x and h of x, with the limit of f of x and h of x to be both L near a, then the limit of g of x as x goes to a must also be L. To understand this better, let's have an illustration. So suppose that x equals a is around here, and we have a function f and h around here. If g of x is in between f of x and h of x near a, then we can inspect instead the limit of f of x and h of x. So around here, inspect the limit of, let's use a different color. So the limit at h of x approaches a is around here, and the limit of f of x as x approaches a is around here. And if these two are equal, then it follows that the limit for g of x, even though we don't know the function g of x, even though we don't know its limit and we can't obtain it, we can immediately determine its limit by squeeze theorem that its limit must also be the same as for f of x and h of x, which is L. So it's something like that. So again, we're only focusing at values near a, so we don't really know what happens out here and out here. So that is the idea in the squeeze theorem. It's like g of x is squeezed between f of x and h of x near a, giving it the same limit as those two. So given that, let's try out some basic examples, starting with this first example. Suppose that g of x is in between 6 minus x raised to 6 and 6 plus x raised to 6. Our goal is to find the limit of g of x as x approaches 0. So before we start, you may pause the video so that you may try this first on your own. Just keep in mind the squeeze theorem that we mentioned earlier. So to start, to solve this, we first take note that if we only focus on g of x, we can't really obtain anything since we don't have a value for this g of x. We don't know its corresponding expression. So given that, what we can do instead is use this and check the limit on the left and on the right, and hopefully we'll obtain something nice. So starting with the limit on the left, we'll have the limit of 6 minus x raised to 6 as x approaches 0. Since this is just a polynomial, we can simply plug in 0 out here. So we'll have 6 minus 0 raised to 6, and then 0 raised to 6 will just cancel out. So we'll be left with 6. For the limit on the right, we'll have the limit of 6 plus x raised to 6 as x approaches 0. Again, this is just a polynomial, so we can just plug in 0 again. So we'll have 6 plus 0 raised to 6, and 0 raised to 6 is just 0, so we'll be left with 6. And observe that these two limits are equal. So it follows that by squeeze theorem, the limit inside, or the limit of g of x, must also be equal to 6. And so this out here is the answer for this problem. So I hope you got that one correctly. The solution is very straightforward. By the way, if you want to have or want to know the proof on the squeeze theorem, you may check out a video around here. I'll link probably around here. So it's a video by Dr. Payam on the proof of squeeze theorem. So essentially, he used the formal definition of limits in proving this one. So you may check that one out if you want. Let's now move on to our second example. So we'll have this one. So we have here f of x to be between 2x plus 6 and 5x minus 9. Our goal is to find the limit of f of x as x approaches 5. So you may pause the video again to try this one first on your own. To solve this, again, observe that if we focus on f of x, we can't really do anything. So we instead focus first on the limit on the left and on the right. Starting with the one on the left, so we'll have the limit as x approaches 5 of 2x plus 6. Again, 2x plus 6 out here is a polynomial, so we can simply plug in 5 out here. So we'll have 2 times 5 plus 6, and then 2 times 5 is equal to 10. 10 plus 6 is equal to 16. So that is the limit for the one on the left. Moving on the limit on the one to the right of f. So we'll have the limit of 5x minus 9 as x approaches 5. This is just a polynomial, so we can simply plug in 5 out here. So we'll have 5 times 5 minus 9. 5 times 5 is equal to 25. 25 minus 9 is equal to 16. And so, clearly, these two are equal. So by squeeze theorem, it follows that the limit inside, or the limit of f of x out here as x approaches 5, must also be equal to 16. And so this out here is the answer for this problem. So as you can see, our examples here are quite basic, and maybe it's still hard to see the significance of the squeeze theorem, but later on in our future video, we'll try out harder examples, especially when dealing with trigonometric limits. So that's something that we hadn't discussed yet, since we need to know first the squeeze theorem in order to solve for limits involving trigonometric functions. So stay tuned for that in the next video. And for now, as an exercise, so you may try to work on this one. Suppose that h of x is in between 4 squared root of 4x plus 9 and 3x plus 8. Our goal is to find the limit of h of x as x approaches 4. So the idea here is similar to our first two examples. So yeah, that's it. I hope you enjoyed and learned a lot from this one. Feel free to comment down below if you have any suggestions, recommendations, or some comments, reactions to this video, or this playlist, or this channel in general. So yeah, that's it, and that's all for this video.